So that's how you do translation or shifting. What we're going to do now is reflecting in the axes. So reflection in the x-axis and reflection in the y-axis. And what does that look like in your formula? So if you have a function f of x and you change it into a function g of x, where g of x equals negative f of x, then that means all your y-coordinates, you get the negative y-coordinate. And so that is your graph of f is reflected in the x-axis to obtain the graph of g. Okay, so the positive y's become negative y's and negative y's become positive y's. Now, if you have another function h of x that you get from f of x by taking the opposite of x, instead of the opposite of y, the opposite of x for every point, that reflects the graph of f of x in the y-axis. So the graph of f is reflected in the y-axis to obtain the graph of h, of the relation h. These don't have to be functions, actually. So here's an example. I just made up this little graph. Don't know what the formula is, doesn't matter, right? So if I did g is actually this. You take the opposite of y for a given x. So it reflected, it's not perfectly right. It should be probably a little bit lower, but it's the reflection in the x-axis, okay? This here would be f of negative x, which I called h of x. It's the graph, the original graph, y equals f of x, is reflected in the y-axis to give me h. Okay, and then just to be complete, there's a fourth one, which is actually called the reflection in the origin, but that's the same as reflecting in the x-axis, then reflecting in the y-axis, or reflecting in the y-axis, then reflecting in the x-axis. Comes out the same. And that's both of them negative. Y equals negative f of negative x equals k of x. Okay? I just made up a letter k for it, function k. In addition to reflection and translating, we can also stretch and compress the graph of our function. So g of x equals a times f of x with a greater than 1 stretches f vertically by a factor of a. So every y value gets multiplied by a, is all that's happening there. H of x equals a times f of x with a between 0 and 1 compresses f vertically. So like a is a half, it compresses it by a factor of a half, for example. So in general, a greater than 0, less than 1 compresses f vertically by a factor of a. So here's an example for you. I've got the same graph that I had before, a horizontal line from 1, 1 to 2, 1, and then a line from there to 3, 2, right? And I'm calling that f of x, y equals f of x. And then y equals 2 of x, I'm calling g of x, it's 2f of x, sorry. Y equals 2f of x, I'm calling g of x. So the graph of g of x starts at 1, 2. The height is twice as much at each point. So when x is 1, y is 2. When x is 2, y is 2. When x is 3, y is now 4. Before it was 2. Now it's 2 times 2 is 4. It's doubled, right? And this is the one for y equals 1/2 f of x. it starts out at 1 comma a half, goes to 2 comma a half, and then there's a line segment from 2 comma a half up to 3 comma 1. It goes up by a half because of the coefficient of 1/2.